Yes, guys, be calm, cool, and with peace of mind, let us concentrate on our subject. Today, we are going to discuss about distance, displacement, speed, and velocity. We will also talk about the uniform and non-uniform motion. Let us learn this concept. Moreover, I am also excited to explain you in practical way. You might also be excited to learn the practical way, and at the end of the video you will do on top 3 questions on this topic. So get ready to stick with your seat. Let us start. Let us see you are traveling like me. How you will calculate the distance traveled? What about your speed of the vehicle? How do you calculate the displacement? Is it the same as distance? What is about velocity? Is it the same as speed? Hold on. Here you have too many questions. Here, so let me stop the car before we answer all these questions. I think it will be good idea to really understand these terms first with the help of the simple example. How do you practically calculate the speed of the vehicle, the distance traveled? How do you calculate the displacement? Is it the same as distance? What about velocity? Is it at the same speed? Let me get out the car. Let us see the view from the top. And your house is here, and your friend's house is exactly at the other end of this park. And there is a road along the path. Let us see you travels to your friend's house like this. So along this road and then along this road. So what is the total distance traveled by you? This is going to be this distance plus this distance. Now how you will practically measure it? That is right. You can use a measuring tape like this. But you need a really long one. Now let us say this length is 40 meters and this length is 30 meters. So what is the total distance traveled? It is going to be 70 meter, and the distance is defined as the total length of the path traveled. Now how you will calculate displacement? Displacement is defined as the shortest distance from the initial to the final position. Your initial position is your house and your final position is your friend's house. So, what is the shortest distance? That is right. It is going to be straight line from here to here. So, how do you calculate the displacement? Again, you can use the long measuring tape like this. Or can you see the right angle triangle here? This is a right angle, right? So we can apply the Pythagoras theorem because the displacement is the hypotenuse of this right angle triangle. So the displacement is going to be the is equal to root of 30 square plus 40 square. But there is no direction specified. But if you look at this displacement, it has the value of 50 meter. Now what is the direction from the initial to the final position? You see on the map. It is northeast. Now your displacement will be northeast from your home. Let us say this is the curved path. the path something like this, and you walk to your friend's house along this curved path. See, you are on the curved path. So the question is, what is your distance and the displacement in this case? Displacement is easy. It is the shortest distance from your initial to the final position. So it is going to be 50 meter again. But how do you calculate this distance? How do you practically measure it? You can take the help of the rope. So let us put distance and displacement on our concept board. Let us talk about speed. Speed is defined as the rate of change of distance. So whenever you use the word rate of change, it means divided by time. So the formula of speed is distance by time. So let us take a look at our example. The distance we have travelled was 70 meter. Now let us say you took 1 minute 40 seconds to reach your friend's house. So how many seconds? That is 100 seconds. 60 plus 40 is equal to 100 seconds. That is right. Now let us plug in the values and calculate your speed. So speed is going to be 70 meter divided by 100 seconds. So that is 0.7 meter per second. So that is the SI unit of the speed, because it is distance by time. So the unit is meter per second. Now let us talk about the velocity. Velocity is defined as the rate of change of displacement. So similar to speed, formula is going to be displacement by time. Now let us look again at our example. Our displacement was 50 meter and the time is same, 1 minute 40 seconds. And your velocity will be right 50 meters by 1 minute is 100 seconds. So that is 0.5 meter per second. So the speed and velocity has the same unit, meter per second. So just like distance and displacement, the scalar vectors pairs. So as speed and velocity, and it is very easy to remember. S for speed and V, S for scalar and V for vector. Now let us go back to our example. The speed we found out was 0.7 meter per second. But there is no sense of direction, because it is the scalar quantity. And what was the velocity? That is right, 0.5 meter per second. So what is the direction of the velocity? Here it is along the northeast direction. So the complete answer of the velocity is 0.5 meter per second northeast, because it is the vector quantity. Now let us see, you came back from your friend's house using this path. But this time you didn't walk but by the bicycle and came back really fast. What is the total distance traveled by you for your entire journey? That is from your house to your friend's house and back. So the total distance is going to be perimeter of that rectangle. So that is fully 40 plus 30 plus 40 plus 30. That is 140 meter. So that is the total of 140 meter. That is the total distance traveled by you. Now what is your displacement? So the initial position was your house. That is also your final position because you have come back here. What is the shortest distance between your initial and the final position? Your total displacement is 0 because that you are back at your home. Now let us talk about the speed. But as your speed is changing, once you are walking and the other time you are riding on your bike. So it makes more sense to talk about average speed. Here speed is distance by time. So the average speed is total distance by total time. And what is the total distance here? It is 140 meter. And what is the total time? It was 100 seconds plus 40 seconds. So your average speed is work out to be 1 meter per second. Now let us look at average velocity. Similarly, it is the formula. Total displacement by total time. But the total displacement here is 0. So that is right. Your average velocity is 0 meter per second. Let us put the speed and velocity on our concept board. Now let us talk about uniform and non-uniform motion. A body is said to be in uniform motion if it is traveling equal distance in equal interval of time and in a straight line. Let us break down this definition. The first part says equal distance in equal interval of time. For example, let us see your car is traveling 10 meter in every seconds. So car is going at constant speed of 10 meter per second. And the second part is it is traveling in a straight line. So direction is constant. So here we have constant speed and constant direction. And as we know that the velocity, it is speed with direction. So car is moving at a constant velocity. And so the uniform motion means the body is traveling at a constant velocity. Non-uniform motion is exactly opposite to this. So does that mean that it travels in equal distance in unequal intervals of time? Hold on. This is really confusing. So the time interval should be kept the same. So the non-uniform motion is where body is moving at unequal distances in equal intervals of time. Let us take an example. Let us say the car is traveling 5 meter in first seconds and then 10 meter in another second and 7 meter in third second. So can you see the distances traveled in every seconds are unequal here? So the speed is changing and in non-uniform motion the speed is not constant. Let us place uniform motion and non-uniform motion on our concept board. Now we have done with our concepts. Are you ready to solve top 3 questions on this topic? Try solving these questions and do post your answers down in the comments below. I promise to reply all your comments as soon as possible. So I am going to be disappear and pause the video here. and take these questions. Friends, I hope the concept of the distance, displacement, speed and velocity are crystal clear to you. But you must be wondering, how do we practically apply this concept in our everyday life? For example, let us see you are traveling to your cousin's house. How do you practically measure the distance you traveled? What is about the displacement, speed and velocity, average speed and average velocity? I am posting a video exactly on this. So please go ahead, like it, subscribe it and share it with your friends. Thank you very much.